Okay, so for third and fourth hour, I'm going to go ahead and start on those additional examples because we were able to cover the rest of the material in class. Number 1, we did for sure in class. I can't remember if both classes got to number 2, so let's talk about number 2. Before I can graph this, I really want to put this into slope-intercept form if possible. So I'm going to go ahead and divide everything by -1. And when you do that, don't forget you have to flip inequalities when you divide by a negative. So instead of less than or equal to, I'm going to have now greater than or equal to -4x plus 5, because a negative divided by a negative is a positive. Y equals mx plus b is very similar to this inequality, so we can still graph our y-intercept at 5 on the y-axis, and we could still use our slope of -4. So we're going to go down 4 over 1, down 4 over 1, down 4 over 1, and then before connecting the dots I should ask myself, okay, is this going to be a solid line or a dotted line? And for this particular problem, it should be a solid line because of the less than or equal to. That's what tells us, the equal to tells us that this should be a solid line. Okay, so now for the shading, we have to figure out where to shade. Let me get my highlighter here. Okay, I want to know where the y's are greater than, that didn't really work, did it? Because of the red on the red, so let's choose a different color, and my screen's jumping all over the place, I apologize. Okay, so we want y's that are greater than or equal to. So if I have a part of the y-axis up here and I have a part of the y-axis down here, which part should we shade? If we want the y's that are greater, all of these values are going to be bigger than the ones below. So this is the part of the graph that we should shade because it includes the y-axis that is greater than. Another option is to test a point. A nice easy point to test is this point 0, 0. If you plug in 0 for y and 0 for x, is 0 greater than or equal to 5? No. So you would not shade this side of the line. It confirms that we have shaded the correct side of the line. Okay, number 3. Y is greater than or equal to 4. This one has a 0 slope, so it is a horizontal line with a y-intercept of 4. So on our y-axis, we've got 4. I asked myself solid or dotted, and because it has the or equal to, we're going to put solid. And then I want the y's that are greater, or y's that are bigger, and the y's that are bigger are on top of the line versus below the line. Okay, so now instead of having y equals for number 4, we're going to have x equals, or x is less than 2, -2. So this is going to be a vertical line through -2. It's going to have an x-intercept but not a y-intercept. Because it's just less than and not or equal to, that tells us we're going to have a dotted line. And now we have to ask ourselves, where are the x's that are less than -2? The x's that are less than -2 are to the left of the line, because all of the x's to the right of the line are going to be bigger than -2. Okay, number 5. Again, we want to put that into slope-intercept form, so I'm going to subtract 5x from both sides. I'm going to divide by a -2, and again we have to flip the sign because we divided by a negative. Here, a negative divided by a negative is a positive 5 over 2x, and then minus 5. Y-intercept is -5 with a slope of 5 over 2. So we're going to rise 5, run 2, rise 5, run 2. We are going to do a dotted line because there's not an or equal to, it's just less than. And then we need to ask ourselves, where are the y's less than? We want y's less than. Well, this part of the y-axis is less than this part of the y-axis, so this is the side that we should shade. Okay, number 6. Y is greater than -x. Some people would automatically assume this is a horizontal line, however it's not. We could put a plus 0 here. That means that the y-intercept is 0. We have a slope of -1 or down 1 over 1. This one should be a dotted line because there's no or equal to. And then we say, okay, we want the y's that are greater. So what part of the y-axis is greater? This part or this part? This part contains the y's that are greater than, so we should shade this side of the line. Okay, writing inequalities given a picture. This is much like writing an equation in slope-intercept form, only you're writing an inequality, so there should be a less than, a greater than or equal to, less than or equal to, something like that in your problem. But you still need a slope and a y-intercept. So for this one, we have a y-intercept of -2, and if you use rise over run between the 2 points, we've got rise 2 and run 3. So our slope is 2/3, our y-intercept is -2. So you would have y, I'm going to leave out the sign for just a second, and 2/3 x minus 2. So if it was y equals mx plus b, we just put an equal sign there, but we have some shading, so we know that it includes an inequality. It is a dotted line, so the or equal to part is not going to be included, and we are shading down or below or less than. For the next one, we have a y-intercept of 0, and it looks like we're going down 1 over 1, down 1 over 1, so a slope of -1. We have a solid line, so that is going to be an or equal to, and we are shaded below the line, so we're going to have y is less than or equal to -x, or -1x. You can put the +0 on there, but you really don't need it. Last one. This is a horizontal line, so you have a slope of 0. You just have a y-intercept, and that y-intercept happens to be 0 as well. It is dotted, so you're not going to have the or equal to part, but we are shaded below the line, so we are going to have less than. Y is less than 0. Okay, so if you are in 3rd or you are in 4th hour, your homework is going to be about the worksheet 6.7, evens. See you in the morning.